The universe is not static, it evolves, changes, and moves toward a final state. But what happens when it finally reaches that point? Not just a slow fading of stars, but a condition where nothing more can happen. Scientists call this the ultimate fate of the cosmos, a stage where all processes stop and the universe becomes fundamentally different from what we know today. From the moment of the Big Bang, the universe has been expanding and cooling. Matter formed, stars ignited, and galaxies took shape. Over billions of years, complexity emerged, but every process consumes energy, and over time, that energy becomes less useful, pushing the universe toward equilibrium. One leading theory is the heat death of the universe. In this scenario, energy becomes evenly distributed across all of space. No gradients remain to drive motion or change. Without differences in energy, nothing can happen, no stars can form, and no work can be done. For in this final state, the universe would be cold and dark, stars would have burned out, and galaxies would no longer shine. Only faint remnants of radiation and isolated particles would remain, drifting through an endless void. Black holes, the last major structures, would dominate for a time. They would consume remaining matter and radiation. But even these objects are not eternal. Through a process known as Hawking radiation, they slowly lose mass and eventually disappear. When the last black hole evaporates, the universe enters an even emptier phase. Only low-energy particles and radiation remain, scattered across an ever-expanding space. There are no sources of light, no structure, and no observers. Time itself becomes difficult to define. Without events or changes, the passage of time loses meaning. The universe would exist in a state where nothing evolves, and nothing marks the progression of moments. Some theories suggest that even particles may not last forever. Protons could decay over extremely long timescales, further simplifying the contents of the universe into basic forms of energy. As expansion continues, distances between particles grow larger, interactions become extremely rare. The universe becomes increasingly empty, approaching a state of near-perfect isolation. Another possibility involves quantum fluctuations. Even in a seemingly empty universe, random energy fluctuations could occur. These events might create brief structures, but they would be temporary and extremely rare. Some scientists propose that these fluctuations could eventually trigger the birth of a new universe. A random event might recreate conditions similar to the Big Bang, starting a new cycle of cosmic evolution. Alternatively, the universe may remain in this final state indefinitely, a cold, silent expanse with no structure and no activity, existing for an infinite amount of time without change. In such a state, the concept of end becomes unclear. If nothing happens and nothing changes, the universe has effectively reached its conclusion. Even though it continues to exist, the final state is not dramatic or explosive. It is quiet, subtle, and inevitable, a gradual fading of all structure until only simplicity remains. This outcome reveals a profound truth about the universe. Everything that forms, evolves, and shines is temporary. Even the largest and most powerful structures cannot last forever. What happens when the universe reaches its final state is not just an ending. It is the disappearance of change itself, a cosmos without events, without motion, and without meaning, leaving behind only a silent, endless existence.